make you understand when to do the job, and then attitude, right attitude when to do the job when required. So these are all very, very important things that you'll have to have. Now, there are a few things, this very important thing, which is interesting Venn diagram that we prepared. One is what you love doing. Second, what you're good at. Like, let's say you love civil engineering or you love water resource, you're good at water resource. That's called passion. Right? You're a good civil engineer, you love civil engineering, you're good at civil engineering. That means it's a passion. Then you are good at civil engineering, you get a job in civil engineering. Right? That is called profession. Right? You love civil engineering, you are good in civil engineering, you are paid for civil engineering job, world needs good civil engineer, that's called vocation. So intersection of all this is what we are trying to do. Now what is happening in the world? World wants a lot of software engineers. Right? So I come here where the world needs. You are a civil engineer, but you are not getting a job in civil engineering, you are going with software. So you are good in this, but you take a job in which you are not specialized. So what do the IT companies do? When you join an IT company, first 2 months they make you unlearn whatever you learned in 4 years. Right? Next 2 months they make you learn what the company wants you to learn. And you don't leave the company. This is what all companies do. So first 2 months, they make you unlearn whatever you learned, and then you learn what the company wants to do, and then you stay with the company. That's what they all result. So if you're paid for this, it's called vocation. If you're paid, so if you love civil engineering and you get a job in civil engineering, that's called mission. So you find that it's an intersection of anything that you do, you should love it, you must be good in it, you must be paid for that particular thing, the world also needs it. So that's the way we look at this. Is prepared somewhere at about 8-10 years back in ACE journal, American Society of Civil Engineers, and then a lot of things are going on. And the definition of what you're good at and what you are paid for is profession, what you love doing and what you're good at is called passion, what you love doing and what your world needs is mission. Like, you want to be a software engineer no matter what happened, but I get any degree, but I'll go for software. There are people who do that, some degree to get a software job. Okay, so this is something which is happening around the world, and this is something which I want you to know the definition of passion, profession, vocation, and mission. Now, this is a very interesting quotation which I always remember. This was in 1962 when the Nobel Prize award function was going. Whenever somebody gets a Nobel Prize, they are supposed to give a talk. So John F. Kennedy was the president at that time. He made a statement: one to solve the problem of water should be awarded 2 Nobel Prizes. One for science, other one for peace. We are fighting between 2 countries, fighting between 2 states. Right? Now there are 269 rivers in the world which are flowing between 2 or more countries or 2 or more states or 2 or more districts. They are fighting, which includes all the rivers in India and the rivers in Europe, rivers in the US, everywhere. There are 269 rivers which are facing problems. So whenever a river flows between 2 or more countries or 2 or more states, there's a potential for conflict. We call PC. We have potential for conflict. How do you convert the PC to CP? CP is cooperation potential. When a river flows between 2 or more states, there's a potential for conflict. It was converted to cooperation potential and the way to growth. This particular word PCCP was formulated somewhere in 2004, and then probably our Narmada River, Sardar Sarovar Dam, probably one of the first river where it was solved using PCCP. That means the dam is in Gujarat, the submerge is in Madhya Pradesh. So the compensation is Gujarat gets the water for agriculture, but produce agriculture after passing the water through turbine, give the power to Madhya Pradesh. The same dam, power to Madhya Pradesh, irrigation to Gujarat. So the problem is solved. So Madhya Pradesh doesn't mind. So that is one of the interesting that's happening. So this is a very interesting statement, which I always liked, that a person who works in water is getting both in science as well as for peace. There are the interesting, it's a very famous chemist who said, Father Buckminster Fuller, he said, when I'm working on a problem, I never think of beauty. But I think about how to solve the problem. But when I solve the problem, the solution is not beautiful, I know something is wrong. Very, very nicely written, that you don't think about the problem, you never think, you think about beauty, you think about only how to solve the problem, but when I finish, the solution is not beautiful, I know something is wrong. And this is something very nice. When I read something, I note down these things and I put it somewhere, and then I know it's nice to remember such interesting statements. Now, this is the map prepared in the year 2005 to show the water scarcity year 2025. 2 years from now, what is the water scarcity? Now, here you got different colors. The red color shows the physical water scarcity. Physically, what is not available. The yellow color shows there is economic water scarcity. I'll tell you what it means. The blue color shows there is no water scarcity at all. The white color is not the measure. Physical water scarcity means, let us say I want water by agriculture. I have different cropping patterns. I want water for drinking. So you know the population, you know the type of cropping pattern, you know what is the amount of water crop water required, you can calculate. You know the population, if one supplied 100 liters, 135 liters, you know total water. So for the area, if the water is not available, that's called physical water scarcity. Physically, what is not available to meet the demand, right? Yellow color is what is available but no money. Now look at India. The whole this portion, starting from West Bengal to Orissa to Andhra coast to Tamil Nadu, Kerala, then Karnataka and Maharashtra, yellow color. That means money, what is available but no money to develop. The central portion of India, there is physical water scarcity. I'll have a break, small break. Anyway, I can talk, doesn't matter. Isko zarurat nahi hai. Then everybody gets, that's fine. So I want you to remember this map. This was prepared in, see, probably in my next talk, I'll show you how this map was prepared. Map was prepared in 1995, then 2005, and then 2013. It was continuously revised. I was involved in the preparation of this map. This is part of the EV. Okay. This map is clear. Now you just look at this. All red color says there is a physical water scarcity. That starting from India, then Pakistan, Afghanistan, Iran, Iraq, then whole of Gulf, and then north of Africa. All these are red color, right? That is physical water scarcity plus South Africa. Australia, here, it says economic water scarcity. What is not available? They have water but no money. Whole of South America is in yellow color. US, blue color, no water scarcity. Russia, no water scarcity. Europe, no water scarcity. So all the water scarcity are in this region. And whole of Africa. So this is the world status of water projected in 2025. That means another 2 years from now. That was not accepted. So people recalculated. They prepared this map. This was 2013. Okay. So here, this is, you have some numbers here. These are per capita availability of water in meter cube per year per person. Right? If any place has water less than 1,000 cubic meter per person per year, that place is called critically low amount of water. So if you look at here, India is in this color, India is in this range here. 1,000 to 2,500 or 1,700 meter cube per head per year. That India is under water stressed and vulnerable area. Right? Now, all the blue color shows there is no problem. Right now, see, Australia is no problem. Whole of Russia is not a problem. US no problem. South America no problem. Africa, many places not a problem. This is a recent map, 2013, which is accepted across the world, and this is what is being followed for all planning across the world now. So this map I want you to remember. So this is so it ignores storage which overcomes scarcity. Ultimate resource is the seas. Ultimately all the water goes to sea. Right? So that's how so this is how, you see the number is 2013. We are still using this map for all our purpose. Now, when you have water, where there is stress, look at this map. India is in a green color. Green color means there is stress for irrigation. That means if I meet everybody's demand for drinking at whatever rate, I will not have water for irrigation. So India is a country which is water stressed for irrigation. See US, western part of US, California area. Again, that is stressed for irrigation. We got irrigation here. This shows domestic, that means no drinking water also. The red color shows no industry. Okay. The white color shows low stress. So you find whole of India and China there, Pakistan there, Iran, Iraq, northern part, all these are water stress for irrigation. So we should know that we don't have enough water. Now what are disasters? What's the distinction between disaster and hazard? Anybody can tell me? Disaster and hazard. Any difference? Or there must be different, right? Two different words. Anybody can tell me? Wild guess, doesn't matter if it's wrong. Disaster long term. No. Still, anybody else can try? Doesn't matter. It doesn't matter. 100% wrong. Doesn't matter. We'll try. These are event as outcome. Slightly yes. Anybody else? There's a little more. Very very beautiful definition. If a human being is killed, it is disaster. If a human being is not killed, it is hazard. Is earthquake a hazard or disaster? Let us say we are all sitting inside, then earthquake, you all die, that is disaster. We are all outside. Somewhere in the night there's an earthquake comes. This building, that is hazard. So earthquake could be hazard, it could be disaster. The definition is if a human life is involved, it is called hazard. Human life is not involved, it is called disaster. Very simple definition. Many of us don't know this definition because we use it interchangingly everywhere. And English is such a language which which is English is very much Indian language as any other language. What is the correct accent of English? That is British English, right? Right accent is no accent. From the way you speak English, nobody should be able to make out from which part of the world you are coming from. You got Orissa English, you got Bangla English, you got UP English, you got Punjab English, right? For example, in Orissa, you don't say Shah, you say Sa, Odisha, right? And you are very fond of fish. So you go to some hotel in Cuttack. What is today's special? You say today's special is fish curry, fish masala, fish fry, fish cutlet. You start thinking what is wrong. You go to UP, they say is speak, is school, is station. You go to Punjab, they say station, sapeek. Right? So you go to Karnataka, they say world, inform, application forum, garal, R is emphasized. Every state has. So you should learn, and if you go to England, it is something. Go to Australia, it's something else. You go to America, so right accent is no accent. Nobody should be able to make out which part of the world you are coming from. That is the right accent. So in India, we have each region has its own impact. Right? Anyway, so that's a definite disaster. So disasters have been happening since the mankind started coming. So from they continue to strike without any notice. There changes magnitude, change in complexity, frequency, and it affects our economy. Okay. They pose threat to people, structures, economic assets. Why is India called a developing country? When I was like this, India was a developing country. When school, India is a developing country. When I was studying in college, India is a developing country. I'm working for past 40 years, India is a why not India become a developed country? Yes, there should be some reason, right? Yes? Yeah? No, it's not. We're not. See, what happens is, we take equator, take 20 degrees north and south of equator around the world, all the poor countries are lying in that range. Hot climate, economically very poor, all hazards disaster take place only there. Earthquake, flood, drought, everything takes place only there. Tsunamis take place only there. You go farther away, it doesn't take place. So what happens when we develop very much, suddenly one big flood comes, everything collapses. We again start from scratch. So all the countries around that equator plus minus 25 degrees are always perpetually developing. So that's how the thing was. So increasing population, then socio-political economic consideration. So they force people to stay in a place where we should not stay. Because of poverty, people go and stay in low-lying areas, below the bridges when there's no rain. So that becomes a problem. So, and these areas normally get flooded. See here, 90% natural disaster, 95% total disaster related death worldwide occur in less developed countries. I use the word less developed because I always feel India is developed, not highly developed, we are less developed. All countries are now less developed or more developed. So I think I would call it less developed than more developed than. Okay. So you find 4 million lives have been lost due to natural disaster in the regions. Economic loss have been increasing by a factor of 8 times more. That discounting the inflation. So that is a map of India. That is the population affected on an average by floods, disasters. See, China is about 99.07 million population every year. I'm going to give this PPT, so all of you will get this. I request them to give you the presentation. I'm going to leave it on the desktop so you can copy the whole thing so that you can listen to me. Right? So that you, and as I told you, I've written full sentences so that you can read it later at your convenience. These numbers I've taken from the World Disaster Report. So you find in China, annual average population affected about 99.07 million. So it's about 8% China is affected by disaster. India is 6%. It's annual, every year. Bangladesh, Ethiopia, Philippines, Australia. So you find all these countries. Australia is around 12%, which is the problem. Bangladesh highest. Bangladesh because the Brahmaputra, when it comes from there, goes into the sea, and from the Bay of Bengal also the tides come, and the sands are moved inside, and then they form a sort of wall. So Brahmaputra comes from there, comes on both sides of the wall, and every year the cyclone goes and affects it. So annual features happen. So you find this is just to give a number, how much area, how much percent of population affected due to disaster. Disaster includes everything. Your earthquakes, your tsunamis, your floods, your drought. Drought is also a disaster. Okay? I mean, depends on the people involved. So you find geographical distribution of number of major geographical distribution. You can see that. Now, disasters can be natural. What are natural? Earthquake, tsunamis, volcano, glacial output, lightning, okay, cyclones, then human made floods, dust storms, droughts, El Nino, then natural human, this both mix, you have landslides, subsidence, erosion, etc., greenhouse effect, then some natural influence, your crop disease, then insect infestation, forest fire, then acid rain, ozone depletion. These are completely human. Acid rain, landmines, then major traffic accidents, nuclear chemical accidents. So you find that disaster can be classified from natural disaster to human disaster, and where the different level of human disaster considered. I'm sorry about this small slide because I tried to put everything in one picture, so I could the best I could get. But it is readable when you get that. Then you find meteorological, which depend on meteorology, drought, floods, lightning, windstorm, thunderstorm, hailstorm, tornado, all these are meteorological. Then you have got geomorphological, geological, earthquake, tsunami, volcanic eruption, etc. Then ecological, whatever was earlier again classified into different categories here. Okay, technological, armed conflict, landmines, major accidents, nuclear, etc. Whatever is there earlier one, I put here also, but classified differently. Then global environmental, then you got extraterrestrial. Then disaster type, lightning, the impact is instant. When something lightning occurs, you have impact instant. The length of forewarning is how many hours you can want, a second, a few hours. Frequency is random, you cannot predict it. Okay, you take snow. Let us take earthquake. Earthquake duration is seconds or 2 minutes. The length is again seconds, and the frequency is a log normal distribution. Okay, so you can find all types of disasters can be in terms of minutes and hours. In fact, some of them like desertification, it takes years. Crop disease, weeks or months. Okay, so its impact, what's the time it takes, all this can be classified here. And the frequencies, some are seasonal, some are land random. So you can find different type of categories here. That's a typical flood that you see in different places. These are all in Asia. This is Bangkok. Happens year after year after year. Okay, very, very common in Bangkok. This is Bangalore. This is, I got some date here. One of the worst flood, 2007. This year, last year also it happened. Last year it happened in all the IT corridor, Infosys, etc. They flooded. You can just see how the situation is. This last 3-4 days back, Chennai was bad. Their cars were floating. I have a video of that, which I didn't put it in that. This is Hyderabad floods. Okay, this is 2008 floods. This is a real photograph taken and put together. So, when you want to solve the problems which a highly developed countries try to solve is different from the solution that we, from a less developed countries, try to solve. Because we don't have money like highly developed countries. So we have to find solutions which are economically cheaper. And then, interestingly or is unfortunate is that the human life is not given so much importance in countries like India compared to like US. US, every life is important. Here 100 people died, 2-3 days we'll talk, and after that we forget about it. Happened, the great Orissa cyclone in 2000. A lot of people died. How many days we talked about it? Few days, then we forget about it. So life has different value in different places, which is not right. So you find the environment has borne the brunt of this competition, because in countries like India, we don't care so much for environment. We live in dirt. We accept it. We accept so many things. Things are different now under various schemes, so that Swachh Bharat Mission, open defecation, not there. A lot of change have taken place. People have started understanding the cleanliness, but in general, we are still not, culturally we don't change. So we use all the resources from the environment. Obviously what happens, it affects the ecology, it affects the things. And the nature and interest of natural disasters assume newer dimensions, because we continue to use everything in the nature without, say for example in plastic came, we thought it's a wonder material, right? And now we say plastic should not be used. Now how many of you use this bottle? All of you, right? You buy it somewhere? And all of you are civil engineers, right? What is the drinking water standard for you study 3rd year, 4th year? What is the drinking water standard for the IS? What about steel? IS 800. Concrete IS 456. How many of you tell me water? Everybody knows IS 456, IS 800. Nobody knows about this drinking which I am drinking every day. Yes, did any one of you check? No, right? The water that is supplied by municipal corporation to the whole city is IS 10500. IS 10500 is the standard used by the municipal corporation to supply piped water to the whole city. And that is the best standard, because the municipal corporation cannot take risk of supplying bad quality water to 2, 3, 5, 10 lakh population. Right? You see here, this is not mineral water. This is called packaged water. See here, packaged drinking water. This is not mineral water. Right? This has got a standard 14543. 14543 packaged bottled water, whose source is a borewell in the factory premises. These people cannot take surface water. They have to show a borewell in the factory premises, purify it, and supply it to you. This is 14543. Right? Whereas municipal water is 10500 is the lakes, rivers, only the government has the permission to use that water for drinking water supply. No private company can take lakes or rivers for drinking water supply. So they have to show a borewell in the factory premises. Then we got mineral water, where the source are springs of Himalayas, the springs of Eastern Ghats, springs of Western Ghats, springs of Vindhya Satpura Mountains, springs of Nilgiris, springs of Brahmaputra region. They are 14528 and 13528. That is mineral water. It's got 87 minerals, the right proportion. So normally I ask this question when I go for faculty interview, especially environmental engineering. I ask them, can you tell me the standard? I have not got an answer till today. Till today I have not got an answer. Everybody knows IS 456 and 800. Everybody knows, the whole country knows. What does it show? That the teachers who are teaching structures have taught you very well. The people who taught you fluid mechanics, hydrology did not teach you anything. Because people who teach you these subjects are not specialized in, and so anybody teaches those subjects. In every college you'll find structures people are good. You don't find good people teaching water resource and environment. So that's why it shows. It's a very common thing. When I see this in many colleges, it's a very common thing. So this I ask everywhere, at least after today, if you will tell what is the standard of 10500, 14543 and 13528. Like 135 is mineral water. So that's something which you should know. This is something which all of us know. See, what is taught in the class and what we practice, there's a reason. So, okay, so this is something which I told you. And this also I told you, the world's worst disasters tend to occur between Tropic of Cancer and Tropic of Capricorn. I say 23.5 degrees north and south. I put 25 degrees north and south. That's what happens. So this area is inhabited by the poorest countries of the world. And such countries, they repeatedly have problem of tsunamis, and so there's a lot of pressure and economic condition due to high population density. Now if you take urban population density, if you take the livable area in India, let us say, in urban area, livable area means on the riverbed you can't live, mountains you can't live, forest you can't live, actually called livable area, you will find Indian urban population is around 8 to 10,000 people per square kilometer. Okay, you go to Poland, the least density is about 30 to 80 per square kilometer. In US, around 300 people per square kilometer. India is 8,000. So you know the problem? 8,000 people living in 1 square kilometer, you supply the water. When you supply water, wastewater comes. You have to find wastewater treatment system. Solid waste comes. You have to provide power. You have to provide roads. Where is the thing? Urbanization means high density of people in a large number of people living in a small area per square kilometer. For example, in an urban area, you'll have a 30-story building, each story having, say, let's say 8 floors, 8 houses. You find 1,000 people living in one apartment. You go to village, the whole village, 500 people living in a whole village. So problems in village is different from problems in urban area. Lots of things take place. So this is very important. So there is a population pressure. So some countries, this sentence is some countries are trying to remain in this category of developing nations, primarily on account of severe magnitude of disaster. That's why I told you India is permanently developing, because we try to develop, something happens and we try to repeat. Okay. So disaster can be a very strong factor, which is showing the difference between a rich country and a poor country. Poor countries always get disaster, we get used to it. Where a rich country cannot, they don't get used. They take all precautions to see that this don't happen. Like Japan, for example, they're frequently affected by earthquake. They completely changed their design and they have lightweight structures. See, in Latour earthquake, what failed were the big RCC structures. Lightweight structures were still remaining there. So we have to change our design criteria to suit the frequency and things like that. This I just skipped. You can read this. So we have to mitigate means stop or manage. If you don't stop the disasters, if you don't manage it, it will have a dominating effect on the future. Your future is going to have problem. Okay. Now we also find the political system, the economic system, social stability depends on the bridging the gap between rich and poor. If the country which everybody is almost same economic situation, it is different. When there's very rich people, see when something become costly, it doesn't affect the poor people. Poor people will not buy it. Rich people have money to buy it. Who suffers? The middle income people. Middle income people suffer. So when the gap between the rich and poor is balanced, then the problem is different. So that's what I'm saying here. Since the political, economic, and social stability of the world depends on the bridging gap between rich and poor, the mitigation and containment disaster, less developed nations have to take care of an issue of prime importance. So we have to take this as a prime importance. A lot of people are helping us everywhere, so we do this. Now South Asia, we belong to South Asia, is the most vulnerable to both man-made and natural disasters. So all the countries in South Asia have this. Okay. So we have a measure of poverty is there, unplanned urbanization, malnutrition, high population densities, all this together form problems for us. And you can see there's a very interesting saying that in South Asia, you can set your clock by the diurnal rhythm of floods. Like, when the flood comes, you can even set your clock. That it has been happening at a regular intervals, the floods and things like that. Okay. 4 seasons arrive and depart in tandem. We've got 4 seasons. And all types of 4 seasons, your summer, spring, winter, etc. And you also find floods, earthquake, cyclone, drought also keep repeating year after year, only with slight change in the time and place. So this is very specialty about the South Asia. In fact, we study South Asia as a whole. So when we study India, we also take Bangladesh, we study Nepal, we take together. Nepal is another problem, Bhutan is another problem. Here you go to Sri Lanka is another problem. So there is different things that we study. And there's something common to all the places. And you find, if you see the history, South Asian has always affected by all types of natural disasters. And if you look at this, 15 out of 40 major disasters in the world occurred during 1997 to 2000 in South Asia. So what happened in South Asia? They disrupt normal life and affects the whole community, but it also affects all development areas. We don't have money to develop because funds marked for the new projects are not taken up because we have to solve the problem of the disaster which has come. So whatever money we have, again we replow back into that. So this is the flood. Say the moment the flood comes, we stop everything. All money goes to flood relief. In fact, I always mention about the irrigation engineers or revenue department. They're very happy when a disaster comes. Because at that time you can spend money, nobody questions you. Lord is a festival for them. Yes, election time also no accounting. So they do that. So this is something which which happens everywhere. So now let us see. We have to have towards a culture of we have to become prepared for disasters. Since we know what is disaster, we know the history, hundreds of years, so we have to get prepared. So now you find disasters and development have always been dealt with separately. We have to deal them together. Okay. No possible linkage between the two were understood till recent time. Till recent, we didn't understand the difference between disaster and development. If we properly develop, disaster will not be there. We can control disaster. So we assume that disaster happen in vacuum with no relation with social, economic, and institutional context. We assume that when disaster comes, let us see. We don't worry about it. We don't become prepared. Okay. So we always have only emergency management situation. We are not prepared for it. We do only do emergency management system. And then once the disaster comes, we try to send food, we find clothing, and that's what happens. That is not what should be done. Now you find here each year the budget for emergency management are shrinking, and people who are forced to live in the same conditions fall deeper into trap of poverty, more vulnerable. That means budget is limited, and since we are not taking care, the people suffer more. Let's just see some major disasters. High wind, cyclones, storms, etc. People affected. These are some random numbers I took from the source, from different sources. You find droughts and famines. Deaths are maximum in here. Okay, drought. What is drought? There are three types of drought. Yeah, you got meteorological drought, hydrological drought, and agricultural drought. What is that? What is meteorological drought? When the rainfall is, when the annual rainfall less than 90% of the normal annual rainfall. What is normal rainfall? Normally the average of 30 years. Any 30 years. Can take from 1901 to 1930 or 1970 to 70 or 2000, but any 30, because you find all these 30 years remain constant. So it's a long-term average. So if the annual rainfall is less than 90% of the normal rainfall, we call it meteorological drought. Hydrological drought is when the stream flow is less than 90% of the 30 months average. And when the crop water requirement, you are not able to meet the crop water requirement, it is called agricultural drought. So agricultural drought happens because of hydrological drought. Hydrological happens because of the meteorological drought. All these are related. It's only for study purpose, this classification, drought is drought, shortage of water. So you find number of people dying very, very, very high, and number of people affected are very high, and number of people made homeless. Homeless high is in the floods. Okay, so this is some statistics for South Asia. I have taken concept only South Asia because that's the area of our interest. What happens in South Asia doesn't happen in other parts of the world, so that's how we have to take. And there's some statistics which I got up to 2000. This statistic before we entered the new millennium. After millennium, things were different. I just want to show that before new millennium what happened. So here you find some numbers. You find here, these are different 5-year periods almost, and you find maximum happened during this period. 88 to 92, the previous millennium. These are some numbers. These are just to have a feeling that lots of people are getting affected. Okay. Now this is, any guess which is the dam? Any guess? It is in India. This is Sri Salem Dam. Sri Salem Dam is a very interesting, maybe after I'll show you a small video. Let me just check. I might be having it. This dam, this was in 2007, July. Sri Salem Dam is constructed across River Krishna. After Tungabhadra joins Sri Salem, and then for the first time they opened all the gates. So the chief engineer was my student. He said, "Sir, we are opening the gates tomorrow. Would you like to see it?" So I went there, and I had seen this particular photo was taken by me. And can you imagine this rise? This is what you call hydraulic jump. It was around 60 feet, 20 meters. That was the hydraulic jump that happened. And the river is very narrow there, and this is a very tall dam, mainly used for hydropower, not for irrigation, less for irrigation, more for hydropower. And this was when all the gates were open. After that, 2007, last year we again had to open. And Krishna River is one river where every water is used. It runs through Maharashtra, Karnataka, Andhra, Telangana. Every water is used, and there is no surplus water. Very rarely water goes into the sea. So this is one of the very, very beautiful dam, Sri Salem Dam. So now I'll give some examples of how GIS is used in flood studies. So flood occurs around the world, and India is the most flood affected country in the world after Bangladesh. Bangladesh is the first in the world. India is second in the world. Actually, India, Bangladesh are all one country long back. If you see the map of 1900, prepared by Sir Arthur Cotton. You heard about Sir Arthur Cotton? Who did a lot of work on irrigation structures in India. He has written a book, probably by Institute of Engineers. In that book, there's a map of irrigation map of India. India starts from Thailand, from Bangkok up to whole of Pakistan. Pakistan was not existing at that time. Pakistan came only in 1947. You should see the irrigation. It's very interesting to see that. So this is the recent thing after Bangladesh. When did Bangladesh come into picture? Which year? Bangladesh was called East Pakistan earlier. 1971, Bangladesh liberated. That's where Mrs. Indira Gandhi became very famous as a tough lady of the world. So just some statistics, this all of you should know. The annual precipitation, India, average annual precipitation 1100 millimeters. What is India's area? Area of India, geography area of India? Yeah? Any idea? 329 million hectares. Okay. So if you calculate 329 million hectares into 1100, you get 400 million hectare meter of water. So the area of India, 320. This is a common question asked in UPSC, PSC, all questions we ask. Okay, it's very commonly asked. So out of this rainfall of 1100 millimeters average, it's average rainfall for the country. If you look at you get around 250 millimeters in Jaisalmer area of Rajasthan in a year. You get around 11,000 to 12,000 millimeters in Meghalaya, Cherrapunji area. You get around 5,000 millimeters on the western coast of India, Kerala, Karnataka area. Around 1,200 in the east coast and the Deccan Plateau region. So 1,100 is an average of the whole country. Okay, so 75% of the rainfall comes in monsoon season. Out of 1,100, 75% comes in the June to September, causing heavy discharge in all the rivers. All the rivers have water. Then you have sediment deposition, drainage congestion, and the floods and sea tides. And the floods come, sea tide also goes up, there will be more problem. That's what happens in Orissa, West Bengal, Bangladesh, there's a problem there. So you find the area vulnerable to flood is around 40 million hectares. And the average area affected by floods annually is about 6 million hectares. So out of 329 million hectares, 40 million hectares is vulnerable to floods. That's approximately how many percentage it is? 10 to 15%. Right? So India is a flood-prone country. These are some statistics which you should know because these are some common things which textbooks don't give you, but these are collected from various sources. Now, what are the cause of floods? Rivers in speed, lot of discharge in rivers, snow melt in Himalayas region. In south, we have only Himalayas snow melt. Then storm surges, and short intensive storms. Storm coming for 15 minutes, 20 minutes. This short thing is very, very difficult to study because we don't have data. We don't measure short duration rainfall data anywhere. We measure hourly or daily. So suppose, let's say we measure the rainfall at what time? What is the time we measure rainfall? 8:30 in the morning, every day. Okay. We measure 8:30 in the morning. Let us say heavy rainfall has come in the night between 11 and 12. Cause heavy discharge. And all the discharge gone. Morning 8 o'clock when you measure, that rainfall is not known. You don't know that your discharge is gone, so you will get a wrong data. This is what happened because we measured 8:30. So we need to have continuous data if you want to design any urban stormwater drainage. You need at 15-minute interval, 30 minutes. So now we have it. So that is something which happens. I'll give an example. In the year 1986, there's a train which was running from Chennai to Delhi. There's a place called Mancherial, across a river Godavari passes there. There's a small stream whose catchment area is only 30 square kilometers. There's a culvert above the stream. Okay, big rivers, no problem, because there's enough margin between the high flood level and the bottom of the bridge. But small culverts, there's no such bad pressure. So one train passed safely. After 30 minutes, the 15 minutes high intensity rainfall, the smallest catchment became full. The water was running on the rails. Next train went, it derailed. Around 600 people died. So that was the time railways decided that we should analyze all the small catchments in the country, and then we did lot of work. So we find now there are methods to analyze small catchments. So typical, flooding that happens. There's a river, something gets flooded. The river bottom gets silted up or removed. You find low flow, high flow, different things. Then in the cities it happens. Okay, it's a very common thing which you find in major cities. Then you find heavy rains, urbanization. Urbanization, I told you, it makes the area impervious. So it causes the floods. Very common sight nowadays. Then this is some other country. underwater earthquake, not in our country, but it happens in other countries. Snow melt is very other countries. This is monsoon rain, global warming, deforestation. So type of flood, you have a flash flood, river flood, coastal flood, urban flood. Okay, so something could be because duration, slow onset of floods, rapid flood, flash flood, different type of things. And you find here, this is a typical hydrograph, right? In urbanized, what happens? This hydrograph will change like this. When you urbanize, what happens? More water will flow on the land because the area is impervious. And then, since the road is very good, water will run faster. There is a higher peak and faster peak. This is a natural case. Then you have storm flow, you got flood on the top, you got base flow. These are common things which you have studied. So, typical part of hydrograph here. And so, this is something which all of you know. So, floods, we have natural floods, man-made floods. So, some examples which I told earlier. Now, for example, here, breach of dam, breach of barrage. What is a barrage and weir difference? What is gated? What is it? Which is a barrage, which is a weir? Yeah. If you put a gate about, it's called barrage. It's not barrage, it's pronounced barrage. Okay. The right pronounced barrage. Okay. Anyway, that's how it is. Because, see, one interesting example, there's a very interesting article called Spoken English, written by George Bernard Shaw. Heard about George Bernard Shaw? One of the greatest English writers. He writes, there's a word called pedantic affectation. Pedantic affectation means when somebody else whose mother tongue is not my mother tongue speaks my mother tongue better than me. Understand this? Like Shashi Tharoor's English. His English better than many Englishmen's English, right? Englishmen feel bad. And English is one language where you got capital letters and small letters. And English is the only language, there are many languages, like French, you got German, which you got small letters and capital letters. Only English writes I-S, capital, at the beginning of the sentence, middle of the sentence, and end of the sentence. I means hum. Or Englishman felt that he is supreme. If you got German, they say ish, they write small I. French, they write small. English, they write always capital because Englishmen felt they are the supreme most. That's how it is. So George Bernard Shaw says, and pedantic affectation means when somebody else whose mother tongue is not my mother tongue speaks my mother tongue better than me. So we go to England and you want to go somewhere, you ask, stop in the middle of the road and ask a British person, excuse me, can you please show me the way to Charing Cross? That fellow will not help you. He said, this colored fellow speaking such beautiful English. He feels insulted. He said, how can this fellow speak such a good English? He will not help you because it affects him. It's called pedantic affectation. Whereas you stand in the middle of the road, hey, Charing Cross, which way? 10 fellows will come and help you. Some foreigners come, he doesn't know. So, English is such a language where, and Indians speak better English than in English people. Because we learn English as a language, grammatically correct language. Like how many of you can speak Odia correctly without a single English word? You have different dialects of Odia. Or to go to Visakhapatnam area, whichever way you speak some dialect. Go towards Bengal, you got different type of dialect. So it's spoken different way, right? Every language is like that. So that's a thing. Okay. So you find natural floods and man-made floods. The cause of floods, siltation riverbed, inadequacy capacity, riverbank erosion, flow obstruction, okay, cyclones, heavy rainfall, all this together. The natural factors, man-made, from these are classified. Then you find, I just put together here, you got drainage pattern, the catchment size, attempts at management, land use. So all these are problems causing floods. So you find vegetation cover. This varies seasonally. During cropping season, a lot of vegetation cover is there. So this will affect the interception. Then the stem flow, through flow. What is stem flow? I would use stem flow and through fall. When there's a river, a tree, the rain falls on the tree, then the water comes along the branches and along the trunk and reaches the ground. That's called stem flow. When it rains, the water from the tree it falls down. After the rain, you stand below a tree, you can find water falling on you. That's called through fall. Right? So you find it affects the interception. Interception is that water intercepted by trees. So overland flow is reduced, lag time will be increased. You got climate. So what's the difference between climate and weather? Climate is long duration. Weather is for a day. I don't say today's climate, I say today's weather. Right? You say climate of Bhubaneswar. That means I'm taking the average, whole year. Weather means for short day, today. Right? You say today's weather, don't say today's climate. So climate affects slope. Steep slope will encourage overland flow, and gentle slope will slow and down. So depending on the slope. The rainfall intensity and duration. No civil engineer should talk about rainfall and depth. You all talk about rainfall intensity. Okay. Let us say 100 millimeters rainfall takes place in 1 hour. What's the intensity? 100 millimeters rainfall takes in 1 hour. What's the intensity? 100 mm per hour. 100 mm takes place in 4 hours. What's the intensity? 25 millimeters per hour. 100 millimeters taken half an hour. What's the intensity? 200 millimeters per hour. 100 by half. So if the duration is small, intensity is high. Same amount of depth rainfall coming in a large duration will cause less intense rainfall. So the duration of rainfall is very, very important. Okay? So rainfall duration, then land use, the impermeable surface is created, urbanization will reduce infiltration, soil type and depth, lakes and reservoirs, this will store water, and then reduce the lag time, and then rock type. Okay, so a lot of rocks will have this problem. So these are some of the common factors which affect the flood. So flood control, we have construction of levees, bunds, reservoirs, weirs, to control the waterways. Then riparian node. What is a riparian? What do you mean by riparian? What does riparian mean? Any land which touches the bank of a river is called riparian land. Your land should touch the bank of a river, it's called riparian. So in the riparian zone, erosion control measure must be taken to try and slow down the rivers, natural process. Then flood control such as dams can be built and maintained. Okay. So this is a map prepared for the zones in India. Where are the likely zone floods that can take place? So you find these are all areas where floods can come. This is a map prepared some years back, but still valid. And these are the flood-prone regions you find here. Okay, all the green-colored areas are likely to get flooded in this. Okay, different areas are given here, and that is a flood zone map. This has been done by the government. There's an institute called National Institute of Disaster Management (NIDM). They prepare all this. This was formed after our tsunami. So this is 2001 flood, 11 flood. So heavy rainfall, and these are the areas which were affected. Here Andhra Pradesh is shown mark 2011. Telangana was not existing. It was came out 2014. Now, how do you control floods? Okay. So this is one map of an area which is, you can see the floods. You can zone the area, like some areas where hospital can be there, government office could be there, resident area could be there. There's a river. Okay. By side of the river can have parks, because when the river is running, there will be soil moisture. You don't have to supply water from top. The soil moisture itself can give the required for that. And then slightly away, you can have the university, powerhouse slightly away, factories far away, the residential far away from the flood zone of the river. So that's how normally we do the flood zone mapping. So the dark color frequent flood, and this color once in 25 years, this is once in 100 years. That means when you consider residential areas, you choose areas which are rarely affected, like hospitals, rarely affected. Water supply, should not, once in 100-year flood. Powerhouse, once in 100 years. Industry, university could be a little bit this way or that way, because half the time people may not be there. So this is how a typical flood zone should be done. So here is completely prohibited. Nobody should live, like in summer the river is dry. People go and live here. Okay, and as the water level goes up, this area gets flooded up. So these areas are restricted, you cannot stay there. And then last areas are warning areas. So these areas should never be as far as possible, should never be used for people to stay. That's something which you have to do that. Okay, some regulation, activity limited to water levels correspond 100-year flood. That is called priority 1. Then priority 2 is 25-year flood. Then priority 3 is less economic and community activity. So that's what it is. So priority 3 should be low priority, should never allow there. So typical flood zone area, you can also find road being eroded and gone. Happens because we don't lay the road properly, which is the most exciting structure for a civil engineer. It's the most, what do you call it? Disgusting structure for a civil engineer. Most exciting structure is a dam. You stay in a forest area, construct the dam. After dam is constructed, everybody comes and appreciates the dam. Right? Everybody comes, sees the tourists, everybody goes. Road you lay here, after 6 months, you pay the contractor money, the road breaks. Again, you start repairing it. So every year the roads are continuously under repair. You find something going on always. So I used to tell this to students that how to attract people to water resources. The dam is more exciting. So this is something which normally it happens everywhere. So you have build barriers. Then after the river channel, straighten it, widen it, deepen it, control land use. I told that thing. So this is how you dam it and pump out the water. Most cities are doing it. For example, Lucknow city, we see river Gomti is running there. They dam it and pump the water out into the dam. And build barriers. Strong barriers you can construct so that the water doesn't come to the river to this side. Okay, then you change the channel. If you're going straight, you change the channel. You can change the channel alteration. Then control the land use. Don't allow the house to construct it like this. So that's how you should do. Then you do the floodplain zoning, which I told you some time back. Then emergency measures should always be ready. If something happens, you should immediately be able to supply these things. Then you see this flood is likely to come, and you have a small budget. Just to show the size, that how much is the distance you have to leave when you do the such structures. Now in India we have majorly the floods coming in Brahmaputra region, River Ganga, the northwest, central India, Deccan region. These are the flood prone classification. And Brahmaputra region, heavy siltation. Why they don't structure across Brahmaputra? Because a lot of siltation. Okay. Then you got Ganga River. On the northern banks of Ganga only the problem takes place. Then you find the tributaries like Kosi, Gandak, etc. come there. Then you see the discharge. In Ganga is 57,000 cubic meters per second to 85,000 cubic meters per second. Unimaginably large. Okay, but in spite of it, the inundation is only limited to certain places. In UP, flooding is mostly in the eastern districts. Then Bihar floods are normally confined to rivers north of Bihar. So the best part of Bihar has gone to Jharkhand. Okay, south and central West Bengal, flooding is caused due to inadequate capacity of river channels. Haryana, flooding claims in marginal area of Yamuna. Delhi, on the banks of Yamuna. Then local congestion takes place in different places. Northwest, very less problem there. You don't find problem in Punjab and towards Pakistan. So the flooding is only due to drainage congestion, not due to any other reason. And even Rajasthan, now occasionally floods come. Then south, you find all the states have problems. This is the major Orissa cyclone, the year 2000. This is a picture of Orissa cyclone. This is a nice picture. I thought I should show it to you because this is Orissa. And what is the risk when you have floods? Everything located in the floodplain. The people, the crops, the livestock, machinery, equipment, infrastructure, weak buildings, everything is lost. Right? I'll just skip this. Yeah. What should we do? We have a disaster event, something takes place, we should immediately provide relief. Okay. On provide relief, you have to rehabilitate people in the region. Then you have to reconstruct the whole region. Then you have to mitigate the effect of flood. Be prepared for the next year flood. So this is called disaster management cycle. So we should start basically from here, preparedness, but we start from here. We should be prepared for disaster, but wait for the disaster to happen. See, all of us, many of us have the habit of postponing till the last minute. What is the right word, English word? Procrastination. Right? So what happens, like, let's say, previous day of the exam, you study whole night and study for 3 hour exam. See, there is something called hard work, smart work, wise work. What is hard work? Studying 10 hours to get 3 hours output. Previous day exam, whole night you study, right? What is wise work? Studying 1 hour to get 1 hour output. What is smart work? Studying 15 minutes to get 1 hour output. How do you do this? If you study every day 2 hours, same day, you don't have to study before exam. Just before exam, just look that and go. So hard work is previous exam, you go swallow nice, you forget what to write, you come back and after coming out exam hall, you know the answer. Happens sometimes? Yeah, pata tha, nahi likha. Very common, na? So, but this is what should happen. We should be prepared. So we call it cycle now. We start from preparedness, but we start with actual disaster happening. So that is something which should not be there. Okay, I'm sorry for the color. Shall I change it? Yeah. Okay. So what are the measures you have to take? One is what level warning on danger levels. When the river is coming, every danger level you should have a warning. Some buildings, if you see the old buildings on the bank of a river, you will find floods level marked on the buildings. Along River Ganga, or in fact, I've seen many in Europe. In India, I've seen very less. On the river, they write, this was the flood in 1900, old building. They just mark it. Sometimes even on the piers of the bridges, they can find marks that old floods exist. So that's something. Then you should have a dam safety surveillance unit. So every state has a dam safety unit. So they should have a dam safety surveillance unit. Then all vulnerable areas must be delineated. These are areas which are affected by floods. Then diversion goods, like any important things you should be able to transport. So how do you transport? Then provision of floodlights and generators. During floods, your electricity fails, you have complete darkness, so you need generators, you need floodlights, they must be done. Then airdropping food packets. You have to supply food to the people. Supply drinking water. That's the time when all the water gets polluted. Not polluted, contaminated. What's the difference between contamination and pollution? Pollution and contamination, what's the difference? Pollution can be controlled. Contamination cannot be reversed. It's a long term. You have pollution control board every state. You don't have contamination control board. Right? So contamination is a long term, irreversible action. Pollution can be controlled. Okay, so post-paid operation, like your all SIM, etc. Then there are many departments that are involved. You have Panchayat Raj, you got irrigation department, you got road and transport department, everything. Then press and media, unfortunately, they highlight negative things rather than the. See, now with so many TV channels, you can choose the news which you want to hear. Every channel is attached to a particular political party. If you want to listen to this party, listen to this. If you want to listen to something else, every channel is linked to it. You can choose and listen what you want to listen. So that is something there. Then a lot of NGOs are working. The Disaster Monitoring Center proposed by the Government of India. So here we have structural measures and non-structural measures. So structural measures can have dams and embankments, then detention basins, channel improvement, drainage improvement, diversion of flood waters. So all this must be done during pre-monsoon and post-monsoon. Post-monsoon must be done. These are structural measures. Then you got non-structural measures. That is no structures, but you have floodplain management. Okay, you have flood proofing, you have flood forecasting and warning. That means you're not doing any structures. You are forecasting and warning people. Then you reduce the loss due to flood by giving disaster relief, flood fighting including public health measures, setting up flood forecasting units. So these are all non-structural measures. We'll stop now. We'll continue after lunch. It's 1 o'clock. Yeah. We'll just stop here. This is slide number 84. Okay. We'll stop. We'll continue. For all young students, I always tell that age between 17 and 23, the most important age in one's life. You control these 7 years, your whole life is controlled. You don't control the 7 years, your whole life goes out of control. So you never compromise on this. You will never come back again. Okay, so 17, 20 is very, very important. Sometimes, my classmates who are in various places, and me, if you look at me and my classmates, I look much younger than many of the class. The reason is I am dealing with people who are between 17 and 23. My crowd is only you people now. Because my classmates are executive engineers, they are really old people contacted, they're all, all types of disease. I am very young. But I deal with people like you, I am naughty, people are naughty, I am naughty like you. I am very active in all the social media, I'm really happy with you. So this 6-7 years you must control it. Think good things for you, think good for everybody. Don't keep anything negative. That's how life should go. I mean, it should really, very interesting. I once, I was director of an institute in Kerala called CWR. It's the largest institute in India with 60 scientists working on all PhDs. I was director of a sleep and I can talk. They say there's invisible line connecting the top of the eyes to the bottom of the stomach. As stomach gets loaded, the eyes get closed. Okay, and I have to cut that so that I keep awake. Okay, so we were talking about non-structural measures. Non-structural means where no structures need to be constructed. You only have to do the management plan here. So here, for example, floodplain management. A place where flood is likely to come, you demarcate and then see that people don't settle down there. Okay. Then flood proofing, disaster preparedness, response planning. All these don't require any structures. Okay. Flood fighting, including public health services, like water quality becomes bad. Mostly water is a major, water quality is a major problem at that time. So what is the, let's say, in India we got water quality, you study environmental engineering, right? We got acceptable standard, and then if you cannot meet the standard, you can go up to relaxable standard. You know that? You got two standards. Even the poorest countries don't have that situation. We said if you can't meet, at least go to this level. Our body has become so tough. Even little bit excess, nothing happens. We become immune to such things because of our way of living. Okay. Then forecasting, warning services, it must be very good. They must be prepared well before the flood that you are going to do it. Then Central Water Commission of Government of India, they maintain 157 stations for issuing flood forecasts. With all the major rivers, there are places. 152 for water stage. Stage means water levels. And 25 for inflow forecast, how much water is likely to come for all the major reservoirs in the country. Now, how do you classify reservoirs, major, medium, and minor? In any reservoir which can irrigate more than 10,000 hectares of land is called major project. 2,000 to 10,000 is called medium projects. Less than 2,000 is minor projects. Like Hirakud is a major project. Right? So major project means anything which can irrigate more than 10,000 hectares. Right? So for all the major reservoirs in the country, they have forecasting, and plus 11 in flood-prone stage. I showed you a map where floods are likely to come. So in those places, there are 11 flood-prone states and 2 union territories, Delhi and Dadra and Nagar Haveli. These are the places where these stations are made. Now, recently, some more states have been included. It must be around 180 now. This was 2 years back. So some more have been added after last year, because even the cities are getting flooded. So they also put such stations in the cities. Then we have to prepare against flood. So we have to prepare a master plan for the state. So no state has done it. So we have to prepare master plan state. That means for each district, what will you do if flood comes? So contingent for each district. And this must be done not when the flood comes, much before the flood comes, before the onset of monsoon. So, and do the post-flood management. After the flood comes, what happens? So you must plan it well before, during floods, before floods, and after floods. Not just after the flood comes. Okay, I'll give a small example. In 2018, Kerala had a major flood. Right? I was one of the person who had done a study there. So we had done a study and found that there's going to be heavy rainfall during August 13, 14, 15 of that year. Right? We were there in July. We found all the reservoirs were full because some rains have come. So we wanted the water level to be reduced so that when the rain comes, the reservoir can again be full. So we advise them to how to release the water. We give a plan also without water overflowing the bank of a river. What you release must be within the bank. But they didn't do it. The reservoirs were full. Suddenly, 13, 14, 15, as expected, heavy floods. And reservoirs were full. The government opened all the gates. And 55% state was under flood. Later on, they saw a report. The problem there was the dams are controlled by the electricity board, not by the irrigation department. Electricity board wants the head of water to produce power. So we reduce the head, power is not there. Irrigation department wants to protect the dam. So Kerala is one of the states where all the dams are controlled by the electricity board rather than the irrigation department. So there's a lot of problems. So there must be good coordination between the electricity department and the water resource irrigation department, depending on which state it works, they must work together. and any engineer should be able to take the risk. See, suppose we ask them to reduce the water. Suppose it is not rained. The water is lost. Then power is lost. So we should be able to get power from other state because some risk we should take. Nothing can be 100% foolproof. Right? So what some essential components before what you should do? Pre-monsoon inspection. When all the railway tracks, before rain itself, you go and check the railway tracks, canals, drains by the respective department, including silt and debris clearance from seasonal small streams. Then regular clearance of drains from silt and weeds to make drainage system fully functional, restore them, then maintain embankment of rivers, canal, distribute, etc. Clearing stormwater and sewage system in the town cities before monsoon. Then have many committees for emergency services like doctors, police, transportation, and the district administration to ensure proper coordination during the crisis. So all this must be done before the rain starts. By the state and district administration, review the contingency plan, update, modify it if deemed necessary, coordinate the NGOs and community-based organizations, review and visit the likely places for evacuation to ensure their functional availability. Like you want to evacuate, you should find people, when they evacuate to a particular place, people should be able to live there. Make people aware of the warning mechanism. Then have a list of do's and don'ts. This is the thing you should do, this and don't do it. So make a list, this is what the government should do. Then when the response mechanism is, once a warning comes, people have to immediately respond. So we must actually train the people by this response mechanism. So normally for floods, enough early warning time is normally available for the purpose. The flood is coming from, let us say, the flood is from here, the rain water is flowing like this. The moment I know the flood here, I can find out what will be flood here because we know the flood routing mechanism. We know how much time it will take for water to reach from here to here. We know what the water level, we know what's the discharge. All of you study flood routing, right? Muskingum method, etc. What is Muskingum? Muskingum is a name of a river, not the name of a person. It's one of the few models named after a place. Normally every equation is named after the scientist. Muskingum method is used for a river. The first time it is used. So you can use this and then predict what is the flood coming there. Then you should also give newspaper media, newspaper, print, now your Facebook, WhatsApp, YouTube, the continuous mechanism given. So the electronic media, and you have to inform the authorities concerned. In remote areas where nothing is available, people can go and beat drums, sound of sirens, village gongs if any, or by word of mouth. So all these are possible. Okay? One word is missing. Yeah. Sometimes when you type, your brain works faster than your brain is still young, hands are old. Yeah, so your hands don't move as fast as your. Many times when I write, what happens? Some paragraphs are missing because I think so fast. My hands don't keep space with the speed which I'm thinking. So I may find afterwards I read some words are missing. It happens to many of you also sometimes, right? So this is important. So what a general observation? What happens is largest cause of loss of life is through house collapse. Right? Houses collapse in the places. Then what do you do? Safety, you have to evacuate people. When they know something is going to happen, evacuate people to safe place. So there must be shelters. Where do you construct shelter? In a place above the danger level. You identify such places. Okay, along with people should be able to move there. And when you move people, let's say for 1 week, you have enough food for 1 week, blankets, some clothes, etc., etc. You should be able to have there. Plus drinking water, all this must be kept. Then safe places in higher elevation, preferably pakka buildings, schools, panchayat office, other places, and private buildings. If there's anything in the higher places, you block them. Then you have to provide food, safe drinking water, hygiene, medicine, etc., etc. in this area. So we normally keep it there. Then we have to also tell people how to move. So you do an exercise much before the floods. You tell people how to move. So a drill must be done, telling people where to go in place of calamity. Okay. So many times when the reason for non-vacation is when people go to a new place, their house gets abandoned. Right? What will happen to the house? People are scared. They have to leave their house and go. So they should feel that your house which you are leaving will be safe when you come back. When you are staying there, you have problems, so they must be prepared that is going to be safe. The two activities, the administration relief, how do you do that? And search and rescue, you have to also search at people and rescue. Usually use the locally available material. Okay. In case emergency, military people can be called, it happens. And people from the marooned area, Navy, etc., they come, they do it. Then all these type of things can be done. Then you do the damage assessment, how much is the damage? So district administration, state administration is there. All aspects of public-private property must be included, including loss of crops, agriculture will be faced, so government pays compensation. Okay, then you have to prepare inventory in case something goes wrong, what are the things I must do, including an estimate is prepared. If the calamity is beyond the state government's capacity, then the central government should come into picture. I mean, without politics coming into picture. Okay, that is very, very important. Then after the flood comes, we have to post-flood, we have to restore the roads, restore the railway lines, restore the postal services, water supply should be restored, repair of power, telephone and sewage lines, arrangement for food, shelter and clothing to the maroon people, then survey team to assess the damage, the assistant to repair, rebuild private properties, desilting, dewatering inland areas, then agriculture sector, any contingency plans. I'll give a case study which we have done. This is one of my best master's thesis which is carried out, which is being followed even today. So this Bhadrachalam town is a very famous town where you have the famous Sri Ram temple. And Bhadravati, the river Godavari takes a very sharp turn like this at that place. When it takes sharp turn, the river Godavari becomes narrow. When the river becomes narrow, the water level goes up. Right? Because width is reduced, the same quantities go, the water level will go up. The same thing that happened in Kashmir. Kashmir flood 2015, the Dal Lake was full and it was overflowing. From Kashmir, water enters Himachal, both sides granite rocks. So the river is narrow, water went up, went backwards, and there was flood. Because Dal Lake area was reduced. People started encroaching on the area of Dal Lake is reduced, no capacity. It's a Kashmir flood should never have happened. It's a man-made flood. So here, this town is historical. This mistake comes. Okay, and this town is always flood prone. Okay, so that is the study that we had. So the data we initially collected, settlements, what are the areas around the town, then the roads, river cross sections, from the Survey of India topography we collected, then flood pattern we prepared from the closed contour information. A contour level, if you know, with different contours, you know what the area getting flooded. Satellite data during floods, and ground observation. We also found the socio-economic data. What are the people? Normally, poor people's areas submerged most of the time. Because they are the people who buy property in the low-lying area. Rich people, they construct in a safe place. So then we used this ERDAS Imagine pattern recognition and ArcInfo GIS for the develop the model. So this is the picture that we got. Now you see here, but the river is take a sharp turn here like this. Okay, that's a town, and this is a satellite photograph that we got. These are the areas which are likely to be, when the water level goes up, this area gets flooded. Some areas get flooded here, some areas get flooded here. There's a forest area down. So this photograph we got from the satellite image, and this was reasonably good picture that we got. This is probably best photograph that we got. It was at 24th August. August means there will be cloud. The cloud is there, we don't get proper pictures. So this is the best that we could get from the data that is available. Now this we digitized it. Now you find this is the river. Okay. And the green ones are settlements, means where villages or people are staying. And the other one, this is the road network. This is the road network. So you know, at various places where people live. So this map is available to us. This was prepared, is the first area that we prepared. This boy who did MTech with me, he actually went to the site, got all this information, and it took 3-4 months more to finish it. He said, sir, till I finish, I don't want to submit. I said, fine, I'll support you. So we did that. And then we prepared how to identify whether there is any effect and list of affected villages, list of village route, water levels, all this we collected. There's some flow chart. So let us not forget about this. And then we present water level, forecast water level, danger level. So these things we identified. Based on that, we identify how to identify the flood affected area. Okay, then how to evacuate. We select the village, estimate how many people are affected. So if you know a village, maybe 100,000 population, 1,000 people must be moved. Okay, then we have to identify shelter, where these people will move. We have to identify shelter and whether shelter capacity is there. Suppose I have to move 1,000 people. Can 1,000 people live in the place? Whether the toilet facilities, bathing facilities. Because if there are no proper shelter, it will be creating more problem than solving the problem. Right? For example, even when you have wastewater treatment system, if the wastewater treatment system doesn't work, it is worse than not having a system. It's better not to have a system than have a system which doesn't work. Okay, wastewater treatment, you take it to the end of the city. All the city wastewater goes there. If it doesn't work, it is dangerous. So it's always you should have that there is enough capacity. Then whether roads are available during floods, what happens is roads are wet. The roads are wet, you cannot move faster. The road capacity is also less. We can't move everybody at the same time. So we have to find out the condition of the road, how fast you can move. Okay, then we have to identify then once the road network is there, we have to send which people go to which place, from which village people go to which shelter. So we have to allocate people to different shelters, then identify the evacuation route for the affected population. So that is what we planned. And we collected their water level at different places. For the past, we had all the water levels. And we prepared this map. Like for example, they still, unfortunately, irrigation department still measure water in feet only. They're not converted, changed into meters. So you see here, this red color, this is the river, where the maximum water level is 43 feet from the datum. The red color is 63 feet. The water level goes up by 20 feet higher. Then all the red color village will be underwater. It goes 70 feet. Then the green color area will be underwater. So depending on the water level, you know which are the areas which are likely to be underwater. So this we can, once the contour maps are prepared, and once the settlement which we have prepared earlier is available, this map can be prepared. It's easy, it's not very difficult. Then we have the road network. So this is the second thing that we did, that we identified at different levels. I just took two because we had every 5 feet level, but then we identified this as the critical one and we prepared this. Once we prepared this, then we prepared the road network. Now there are two shelters. One is a temple here, one is a school. Both are at the river level, maximum here, the one is here, the other one is here. So one on the eastern side, one on the western side. Okay. So you find the same thing, red color is this, the previous map which you saw, that is now, this is zoomed. The whole area, I have now zoomed only for a small portion. This. Okay, this is on the, there's a Godavari river on the left side. So now the road network, so that all the red colored road, all these people move here, all the blue colored people come here. So depending on the capacity of the road, width of the road, and the slippery road, capacity road, we identify the villages and ask them people to move in that road. So this is one of the routes we prepared for, and this is being used even today. Last time there's a flood, people immediately said REC Warangal model use. So we feel very happy when the people talk about this model, that is a very, very, and each of this place can, about 1,000 people can stay. There's a school, and this temple is a very famous temple. So it's on a hill. So around the temple we made space. So before the floods come, we store food, clothing, water, etc. for 15 days for about 1,000 people. So when people go there, everything is available. So they don't have to worry about anything, including children, everybody, everything taken care of. Somebody cooks food for them, all this are being done. So this is one of the things that we did. And this is a case study that we did. So water level at 63 feet, if forecast at 70 feet, where people will move. This is another network. The second type of route, if all these people move to this temple, all these people move here. Red color is moving to that. That is the easiest route, depending on the population density, the capacity of the road, and how people can move. Okay, so that is the second route that we prepared. And so you find here, this is evacuation route to temple, blue one, red color is to the school. And route, there are two different routes we prepared, and this is what is being followed even today. Okay, then once the these routes are prepared, they are ready, so we give warning. First warning is when the precautionary stage, when the water level reaches 43 feet at Bhadrachalam, we give the first warning. When it reaches 48 feet, 5 feet more, the second warning. That means to be sure when the flood level reaches 48 feet. Third warning is when the water level reaches 53 feet. We tell the people move. So this is done by the district administration, so people start moving. And then all the three warnings are communicated through radio message, through very high frequency sets, VHF sets, telephone, and sets indicating Godavari water level. So these are continuously given water level going up. So people, everybody in the Godavari area they say 43, 48, 53, everybody knows these numbers. Even a child knows 43 feet is dangerous, 48 is dangerous. Everybody knows, because people go out speaking, most gossips are about 43, 48, 53 only. And this number also we also remember. Whenever I see Godavari, I also remember 48, 53, 58. Okay, so then in the temple, every temple, religious places will have mics, right? So through the temple mics, people announce from the temple that water level is going up. So that's another thing we made. So temples are normally that are used for pujas and things like this. They do flood. They also do the announcement of this type of things. Okay. So what happens is the district administration, that being the district collector, police, they supply essential commodities to relief camps. So relief camps are at the two places, the temple and the school. The public energy department shipped all electrical motors of Bhadrachalam water supply scheme and keep oil engine to have uninterrupted chlorinated water. That means the public energy department will take care of the pumping of water. This is whatever is required. Because many times what happens, electricity fails. You need diesel for running the pump. So they do that. Hospitals to be ready with the medicines. Most of the common medicine must be available. And medicine is another big racket. Nobody knows the real rate of medicines. You go to some hospital, the same medicine will have different rates. Medicine prepared by one company will be 50 paisa, and the same medicine prepared by another company 6 rupees. Which one to buy? So it's one of the biggest rackets that you have. So, but then medicine must be ready. Then fire officers must be there, firefighting officers. People have to move. So these things are all kept ready at that time. Then we have some drainage. So this is what we did for Bhadrachalam, which is working even today. Okay, this I just see. I'll just cover this. Yeah, this is one term I want you to remember. So that entire evacuation was done using GIS anymore. We took satellite photographs, everything was extracted from that, we prepared the map. Now these are some terms which you are going to hear, whether you like it or for next 20 years. LID, low impact development. Whenever you do any development, it will have minimum impact on the hydrology. That means pre-development hydrology and post-development hydrology must be same. You cannot alter the hydrological cycle by development. So that is what you call LID. You are going to hear this for next few years. And then WSUD, water sensitive urban design. Any urban design must be sensitive to water. Okay, so this and sustainable urban drainage system. That means you don't spend again. Now these lines which are underlined, low impact development, terms used to describe land planning, engineering approach, conservation for on-site natural features to protect the water quality. That means all this we are doing to protect the water quality. And to replicate pre-development hydrological cycle, that means the hydrological cycle before the development must be same, or watershed through infiltrating, filtering and evaporating and detaining runoff close to its source. That means any water that is going out should be taken to close. So this term you are going to hear very, very often, next 20 years. This is a term which we are speaking every day. In fact, many times when I speak, I always use the word water-sensitive urban design. Let me ask you a question. How much water is required to grow 1 kg of rice? From the time you sow the seed till you harvest, how much water is required to grow 1 kg of rice? Any idea? Yeah? Wild guess. Doesn't matter. Any number. Wild guess. 50 liters, 100 liters, 1000 liters, 5000 liters, 10,000 liters. You'll be surprised. 1 kg of rice to grow, it takes around 4,000 liters of water. From the time you sow the seed till you harvest, 120 days is the time, crop period, right? If you take all the water, for example, you take 1 hectare of land, in 1 hectare 5 tons of rice grow. So 1 hectare, the duty of water, delta of water rice is 1200 mm. So 1 hectare into 12 mm is 12,000 cubic meters. And it gets 4 tons of kg, 4 tons of rice in one thing. So divide 12,000 by 4, you have 3,000. 3 cubic meters, 3,000 liters per kg of rice. So when you eat meal, you had vegetarian meals right now? Yes? You had 150 grams of rice, some vegetables, some mushroom. Yes? All this requires water. Isn't it? Vegetable dal requires water. So if you calculate the amount of water required for one vegetarian meal, you'll be surprised, it's actually 4,500 liters of water. Then when you eat a good vegetarian meal, you're eating 4,500 liters of water and drink 1 glass to push that inside. So this is called virtual water. It's a term we are going to hear. See, in a place where there is no water, don't send 3,000 liters to grow 1 kg of rice. 3,000 liters means 1 truckload, 1 tanker, right? Don't send 1 tanker of water to a village where there is no water to grow rice. Instead, send 1 tanker of rice and make the villages employable. Give them employment. Let them buy rice. Don't send water to a place where there is no water to grow rice. So we convert everything. This is called virtual water. So we calculated this somewhere in 2004. How much water is required for wheat? How much is required for every vegetable? We calculate. It's available now on the net. It's called virtual water. So everything. Suppose I import rice from other country. Let's say I import 1,000 tons of rice. So 1,000 tons into so many liters of water. You are importing actually so much of water from the country. You are exporting rice. Calculate in terms of water. So everything can be calculated in terms of water. How much you are importing, how much exporting. For everything, water can be calculated water. So that is the present trend. Water is a major trade that we are thinking about. It's very, very important. Everybody talks about it. Okay. So these two terms you will be always hearing next 20, 25 years. Probably till you join a job and retire, you'll keep on hearing this. Make it water sensitive. Any design should be water sensitive. In a developing urban area, it must be sensitive to water. Now, when you want to supply water, we supply in our house, the same pipeline runs through my kitchen, my bathroom, my toilet, and my garden, right? So same water which I use for cooking, I use for flushing my toilet. Is it not? Same pipeline runs in the house. Why should I use such good quality water for flushing my toilet? Right? So what I do normally is, let's say when I supply 100 liters, 80 liters comes as waste. Right? I wash vegetables, I wash clothes, so all the 80 liters comes as waste. So in a house, let us say there are 4 people. I supply each person 100 liters, 400 liters. 320 liters comes as waste. If 320 is recycled into the flushing cistern, not for drinking, your bathroom door should come from recycled water. So suppose a community, all the water goes there, recycle, put it in your toilets. And gardening, because that water you're not going to drink. So it is criminal to use good quality water for flushing the toilet and gardening. So this is the new trend. Now have a 2-pipe system. 1 pipe for supplying good quality water, the second pipe for supplying, for recycling the water for your toilet and gardening. So that's the new trend now. Every new house, they ask us to do a double pipe system. Okay. So that is a new term they're going to listen. So when you do the LID, then low impact development, your habitat is protected, like animals, and birds, everything. Then water quantity is is protected because you are going to maintain pre-development hydrology, so that means no flooding. Okay, then impervious surface will be reduced because you are going to have low impact development. That means your road will be with porous media. Like, when the water falls on the road, it goes into the ground. Right? And groundwater recharge will take place through infiltration. Water quality improvement will be there. Community value will be there. Once the area is not getting flooded, the value of the property becomes more, and then a lot of cost savings. Okay. Now, there are major problems that we face in estimating runoff. One is, when you want to estimate runoff, the data is not available. You want to develop some water supply system or drainage system, you don't get it. It's a problem which all of us face. Second is, data available but not adequate. I have data for 3 years. The 3 years may be very wet year. I design based on that, I'll be over designing. Or I have 3 years of 3 dry years, I'll be under designing. So I don't have enough data. That's the second problem we face. One is no data. Second one, data available but not adequate. Third one is lot of data available but not reliable. That means people have just sat in their office and written numbers without going to site. It happens. During rainy season, the engineers or people are supposed to collect data, they don't go to the site. They sit in the room and write numbers, fill up registers like this, lot of data, nothing is correct. In fact, I had a similar problem once when we did drainage system in Lucknow city. We found, how to calculate the data is right or not. You know the rainfall. You can calculate the runoff using your rational formula, whatever. If the runoff cannot be more than the rainfall, isn't it? You convert everything in terms of millimeter, your runoff should be less than your rainfall, because rainfall is which causes runoff. You convert everything to the same unit, millimeters, then, so you found in Lucknow, the rainfall was 10 times, 11 times more than runoff was 10, 11 times more. Then we actually went to the site and we found a lot of wrong things. Then I gave a report in 96 or 86 or 7, how not to collect data. So one of the report I gave to Lucknow Development Authority that time. So these things are all happening. So that's a major problem. Now when daily rainfall data is not available, you have whatever isopluvial maps given by Government of India, which gives you data. They have prepared a map for the whole country. Maximum likely rainfall for different durations. That map is available with Government of India, free of cost. Anybody want, they can get it. That's called isopluvial map. Or there's a formula called IMD's 1/3 rule, which can be used for getting this data. I'm not expecting to go deep into that. And then, this I won't. I do talk about this. So let us stop this session here. So I'll stop this flood management. I'll talk another case study now. So if there's any difficulty, you can ask me, or you can send me an email. I'll definitely answer you within 24 hours. Okay, so you can, if you have 5 minutes, if you want to ask now anything, because sometimes you're not able to react immediately. Okay, you can contact me later and just send a mail, and then I will definitely reply to you. Not necessarily with what I talked today, but also about your career, about your whatever you want to do, please feel free to talk to me. And that's my last slide for this session. This slide is very, very important for me. This is a small lake in the city of Calicut in Kerala. It's a lake in the urban area. A lot of wastewater is going. So we took a project to clean the wastewater without using chemicals, without power, by just growing certain plants. There are certain plants which are available which enjoy wastewater. So we use these plants, and about 4 to 6 plants per square meter. If you grow, the water quality improves by 90%. Your BOD reduction by 95%. What is BOD? What's the drinking water BOD? How much should be BOD drinking water? 0, correct? There should not be any oxygen demand, right? 0. This can, from normally wastewater, the municipal wastewater will have around 250 BOD. This I could reduce to up to less than 10 just by using this plant. So once we clean this, these are my hands. I was taking water. One of my scientists told me, sir, please hold it. Let me take a photograph. And I got an award for this at the national level for improving the water quality by a natural method. No power, no chemical, and is being used in many places in the country. Yeah, so that is the end of flood management portion. Are there any questions you want to ask now? or you would like to ask later? There are three things when you don't ask. One is you understood everything. Other, you don't understand anything. Third one is you're afraid of your language. This also happens. And fourth thing I found with my students is that why should I ask the question in front of everybody? Everybody will know. I'll go to sir's room separately and ask. Present trend is like that. They don't ask question in the class. They'll come to my room and ask. Because they don't know others' room, because competition. They'll come to, so when they come to my I showed this map in the morning, it was revised, and then further revised to this map. This also I showed in the morning. So this is just to connect the morning stock and present stock. That's how it is. Now there's a word called sustainability. Everybody's here about sustainability. Okay, that means I do something. I don't expect my future generation to suffer because of what mistake I do. I believe the future generation will take care of themselves. I should not spoil their generation. So this definition of meeting the needs of the present without compromising on the ability of the future generation to meet their own needs. That means I do something now, but I don't compromise on the ability of the future generation. This was given by Madam Brundtland. She was the Prime Minister of Norway, and this was probably one of the best definitions that we have in the Sustainability Development Goals. Now we are talking about Sustainable Development Goals, right? So 1987, this is one of the very beautiful definitions that we had. And sustainability could be technically sustainable. It could be environmentally sustainable, that we should not make any environmental damage. Financially sustainable, socially sustainable, and institutionally sustainable. So different levels of sustainability is what is discussed. And this discussion you can read. I'm going to give this link to you. You can read it at your convenience. Now, main challenges to achieve water scarcity, water security. We want water to be secure. Everybody should get water. One is meeting the basic needs. So, if there's enough water to meet everybody's basic needs, that is safe and sufficient water and sanitation are basic human needs. And we empower people, especially women, because in less developed countries, women suffer the most. In highly developed countries, there's no difference between men and women. In fact, our country, I'll tell you one very interesting experience I had. I was invited as a guest to address some women's science, STEM, science, technology, and engineering management conference. Where all were women. And then there's no men there. I say any women's conference, 50% should be men, to sensitize men that women are capable, if not better than you. Otherwise, nothing happens. Women talk, women listen, women clap and go, same nonsense happens. So any women's conference, there are 50% men to sensitize men that women are as good, if not better than you. Okay, so that is what, and I have 3 daughters who are doing very well, so I tell them I live with 4 women at home. I know how successful women are. Right? So it's very important that any women's conference, it is, both are equally, there's no gender bias. So very important that women must be empowered so that in the decision making, women participation is very, very important. Then securing food supply. Food must be given. So for water security, everybody should get adequate food. There should not be any malnutrition. There should not be people dying due to hunger. So, and especially poor people die due to hunger. So that should not be there. So there's more efficient mobilization and more allocation of water. Then reliable. Whether in small towns or mega cities or single or multi-village schemes, piped water is never distributed for more than a few hours a day. Now the new concept is 24/7 water supply. You know that? Is it correct to give 24/7 water supply? Or is it okay if I give 2 hours water supply every day? Which is better? 24/7, all 24 hours you get water? Or 2 hours per day or 3 hours per day? Which is better? How many say 24/7? How many say 2 hours per day, 3 hours per day? Some are not interested in anything. Either it should be this or that, isn't it? 24/7 or 2 hours? How many say 2 hours, 3 hours per day is better? 24/7? Only 3 or 4. Why? Why 24/7 is better? Yeah? No waste. See, when you get water only 2-3 hours a day, you fill up water every vessel in your house. Next day, the water comes next day, then you throw this water and then collect new water. When you get 24/7, that means the moment you on the tap, water is coming, you don't store water. You don't need to, because just like put the switch, you get light. Like that, when you on the thing, you get water. So when 2002, when this 24/7 water supply started, I was also part of the team. I was opposing it, like all of you. Later on, I found there is 60% savings in water if you have 24/7 water supply. We tested it in many cantonment areas, military areas, and then tried to do it in many cities. So that's how it is. Okay. And in India, most of the time, the urban drainage system is open drain. In other countries, they got closed drain. Here we have open drains. Okay. So many times they're blocked. That's the problem. Rural areas, hand pumps they use. They can remain out of power for many months. Okay, because nobody repair. Okay. And toilets can be used for other than what is meant for. People store things in the toilets in villages. It's a very common thing. Whether financially sustainable, is there enough money? When I do something, can I get back money? So financial sustainability is very important. That is whether I can get the operational cost, I can get the maintenance cost, whether I can recover the cost. Because when I spend something, I have to get back. Okay, so these are all things which are very important for sustainability. Environment is sustainable, whether I'm creating problem for environment. Okay, so most cities compete with the agricultural sector because when I give water supply to the city, agriculture needs also water for their crops. So whether I give water to agriculture or give water to the city, whether I give water to industries. So there is a competing demand. So there's a problem. Then when villages depend on groundwater only, there is no power, and government now gives free power, so they pump out more water, whether that water is available. So they subsidize the water. This is another problem. Whether affordable, whatever you do, is it affordable? Like for example, how many of us, this water is costing 10 rupees or 20 rupees, that 1 liter bottle? All of us buy this water when you travel by train or whatever. People don't carry, right? Now, how much you pay for the house per month to the municipal corporation? 200 rupees a month, isn't it? How much what do you consume? Let's say municipal supply is at 150 per head per house. If there are 4 people, 150 into 4, 600 liters, multiply by 30, 18,000 liters they supply for 200 rupees. How much is 1 liter costing? Nothing. Right? So we buy 10, 20 liters bottle when you go out. Suppose they charge, we'll consume less, right? How many of us think on these lines? See, water is virtually free. 200 rupees per month is nothing. It doesn't even meet operating cost. Doesn't. So how will municipal corporates survive? Because they charge in terms of kiloliters, 10 rupees per kiloliter or something like that. So, isn't it? Yeah, that is the type of, it's nothing. 10,000, 1 kiloliter is 1,000 liters. 10,000, 10 rupees, how much money? So, one paisa per liter. So, no value. So, it should be affordable. See, if you increase the water rate little more. See, for example, there is one state government which gave free water supply, and some discussion was there. I said, give up to 10,000 liters free per house. Anything above 10,000, charge from 0 to 10, above that. How does electricity board charge you money? First 50 units, some rate. 60, 51 to 100, another rate. Suppose 51, you're charging the next slab rate. Similarly, when you give water supply, first 10,000 give free. If 10,001, you charge for the whole thing. People try to control, isn't it? So it is basically trying to educate people by giving respect to water. That's what it is. So it's affordable. Then user charges are low. Our charges are very low by international standards. Okay. So when you supply water other source, it must be comparable. So you should provide good quality service. So poor may be the beneficiaries, but then most of the time the rich people also take the free water. If you are focusing towards poor, the rich also take the water. I'll show you one picture. So the true challenge is not to increase access to infrastructure to almost 100% of population, but to increase access to reliable, sustainable, affordable service. Don't make it water for 100% population, but whatever you give must be reliable, must be sustainable, must be affordable. India is unlikely to meet this objective unless it adjusts the policies, institutional arrangements, and financial incentive to help improve service delivery. So we are not expecting it now. Now urbanization has water crisis. So in 1950, less than 100 cities with a population in excess of 1 million. By 2025, that number is 650 across the world. Okay. In 2000, we had 23 cities had population exceeding 10 million. On a global scale, half of the world's population will live in urban areas. That is the present trend. Okay, I'll just skip this. Now, this is something which I wanted to learn. India's second largest urban system next to China. India is urbanizing very fast. Now, if you look at the next picture, just see here, in 1991, 26% people are living in city. Okay. In 2001, 10 years later, we had 28% living in city. In 2008, 30%. 2030, 40%. So 40%, and then you see the increase. From 2008 to 30, 250 million people have shifted to city. So we need to provide a lot of facilities for city people. And this is from a very famous book, McKinsey Global Institute Analysis, probably one of the best books in the world on this urbanization. They have done for the whole world. So this I picked up from that particular book. And this is probably one of the best information that you can get. So 40% of India's population likely to be in urban areas in another 5-6 years. So we have to be prepared for that. Then, so what happens as urban population grow, water use will be needed to shift from agriculture to municipal. We have to change from agriculture to municipal and industry. So making decision about allocating water between different sectors become difficult. Whether I should give more to agriculture or more to domestic urban areas or more to industries become difficult. Okay, I'll see some important questions which I just thought I'll make you think on this. How can you improve weather data measurement? Because we don't have proper data measurement. For better hydrological modeling, under intensified and highly spatial temporal isolation of rainfall events. So rainfall, even if you take Bhubaneswar, sometimes when it rains one part of Bhubaneswar, other part of the city doesn't rain. So even in a small city, we have this type of problem. So how can we improve the weather data measurement? That is one thing which is very, very important, which is now lacking. Okay. What is causing the lack of efficiency in process-based hydraulical modeling? Is it only lack of understanding of the phenomena, or lack of representation of phenomena in modeling, or is it lack of high-resolution input data for modeling? With all these problems, we don't get proper data, model doesn't take into care of this, or we have not understood properly. We have something called as factor of safety. What is factor of safety? You studied, right? What is factor of safety? Yes? Anyone? When you design something, you use a factor of safety so that your structure is, I call it factor of ignorance. If I know the system perfect, I will design exact size. Since I do not know, I am not ignorant of many things, I take a higher factor of safety. Right? So many times it is out of ignorance or lack of understanding of the phenomena, I change the factor of safety. Okay. So here this is also important. Then how can, now the machine learning has become very important. Right? So today everybody talk about AI, ML. There's no natural intelligence. Everybody wants artificial intelligence. Natural intelligence is lacking. Okay. So how can the process-based hydrology model compete with the machine learning? Because machine learning is easy. Because once you train the machine, it reproduces exactly what you want. Whereas we don't reproduce. We think differently. So we are not machines. Right? So this is another important question which we are now discussing at the national level. Then you would also think about community behavior, how community behaves, how people behave. Because community behavior is never as part of our modeling. How can you include that? To understand their contribution in water quality deterioration mitigation. How can you involve community in improving the water quality? Like how can you involve them in the mitigation of the water quality deterioration? How can we make the community hydrologically conscious? In many places we have now installed rain gauges in schools to make students collect the rainfall data and give us. Many government schools have rain gauge stations. We train them. We tell them the importance of this. Then what are the initiatives needed? That means we have to make the community hydrologically conscious because water has become so important. I said water sensitive design. Everything design is water sensitive. So we have to make the initiatives needed. There are ocean of studies. So much of studies on climate change. Okay. Are the research going in the right direction? Nobody knows about climate change correctly. We still assume something happens in some country, we go where? Are we going in the right direction? How do we direct the research the right path? How do we do that? How to incorporate knowledge from climate science and hydrology for better impact assessment? How can we better predict the extreme hydrological events? Extreme hydrological events with floods and drought. Just imagine everything is predictive. Let us say every year, let us say today is 11th December, the temperature is so much, the wind velocity is so much, the rainfall is so much, everything is known. Every year, December 11th will be like this. Right? September 15th will be like that. Everything is fixed, let us say. What will happen? Everything is known. August 15th, it will be like this. Temperature, wind velocity, everything is fixed. What will happen? Now still have jobs. Because everything is known, right? Everything is known, right? So because it's uncertainty only, we all do the analysis to find out. So we have to predict the hydrological events correctly. We are still lacking in that predicting hydrological events. We have still understood many things, but still there are a lot of things which we do not know. How to update rainfall IDF relationship, intensity difficult relationship, stormwater drain infrastructure under changing climate scenarios. So the IDF curves are also changing now. Rate of urbanization is rapid. Rate of development infrastructure is not so fast. Urbanization means that the urban population density increases, but urban infrastructure is not increasing. There are no houses, no roads. So there is a mismatch. Then BMPC, best management practices, due to unplanned settlement, difficult to drain the water with natural slope through drains. Okay, you find in one corporation ward, a corporate is he constructed a drain. He stops at the border of his ward. Next time, the other person does, he comes the other direction. They don't follow the natural slope. He fills what, so at the center portion there will be water body. So this happens because of this. Okay, water quality is a major issue. How does water quality come? Because of community behavior. Okay, more than half of the problems that we face are not engineering problems. We try to solve social problems through engineering knowledge. No, many of these are not engineering problems. So this is how it comes. So we'll have to change our thinking. Okay. Yeah. Then we have preference to open drains rather than closed drains. All drains are open drains. We don't have closed drains. Why? Because closed drains are expensive. So in a country like India, we cannot go for a closed drain. We can open drains. Then, because open drains are there, solid waste gets dumped. Solid waste dumped, there is no capacity to drain during rainy season. Okay. And sea level rise and urban flood. Places close to sea areas, coastal areas, the water level rises, urban flood, and it affects the groundwater. Right? So occupying the low-lying area is a major problem. So these are all the problems which we'll have to think and find solutions. Now, just some statistics. In ULB means urban local body, municipalities. In 1950, we had 2,800 municipalities. Now we have 5,200, almost double. Class 1 cities. Class 1 means population about 10 lakhs. We had 7 time of independence. Now we have 550. Metro cities, we had 5. Now we got 75. So obviously, urbanization is growing up very fast without the infrastructure. Okay. And urban areas, all the economy is in urban area. The entire economic activity is taken in urban area. Rural areas, nobody wants it. Okay. Just look at this number. In 1980, 47% of the economy came from urban areas. In 1991, 50%. Today, 75% of the economy is coming from urban areas. So why should people go to rural areas? Except for asking for votes. Everything happens in urban areas only. This is a real contribution to GDP, 73% from urban areas. So that's what is happening. Now this is something which has been happening in every city. In water sector, there's a low level of investments. Investment is very less. Investment is less. The service will be very poor because you're not investing more money. The service is very poor. People are not ready to pay. Low level of willingness to pay. And the people are not ready to pay. Poor cost recovery. The cost recovery very poor. Again, low level of investment, so it becomes cycle. So this is called low level equilibrium trap. We get stuck in a trap. It goes round and round. Now this must be changed. How do we change this? We change by this. We have high level of investments, more investment in the water sector. Then we got better and improved level of service. The service is good, people are ready to pay. When people are ready to pay, higher money comes. When higher money comes, you again have the higher level of investment. So this is what has to be done now. What is the government of India is slowly changing towards this, that from the earlier cycle to a new cycle. That means there is investment in water sector is increasing. This is what we have to achieve now. This is what is happening. Right? Now you know sustainable development goals. Earlier we had Millennium Development Goals. This only one is related with water, goal number 7. There was 8 goals in the year 2000 to be accomplished by 2015. Only 7 relates with water and environment. Whereas this, so you can see all others are nothing to do with water, right? So this is the Millennium Development Goals. Now we have Sustainable Development Goals. There are 17 goals, and water and sanitation have their own goal. Water and sanitation relevant to all countries. So water and sanitation is contribution to all countries, whereas there we have only one. So this was supposed to finish by 15. This is not completed. Now extended up to 2030. So all the SDGs are supposed to be completed. Now people are doing MTech. Please focus your research towards Sustainable Development Goals. Whether your research meets one of the goals of the Sustainable Development Goals, because if your thesis takes care of this, there are a lot of future people ready to take you for postdoc or PhD type of, a lot of funding available. So your thesis should be focused towards achieving Sustainable Development Goals. And SDGs, you can always see net and you can get all of them. Everything is available on the internet. Okay? So water and sanitation is relevant to all the countries. So that is something which you'll have to see. Quickly, so you find here the Sustainable Goal 6 is water and sanitation. It talks about universal water, universal sanitation, water quality, water efficiency, integrated management, and natural ecosystem. All are continuously involved. This is a, in SDG, everything is involved. There's a spelling mistake here, which I corrected here. You know, when you take an English word, the first letter, last letter are correct. In between, put this way, that way, you don't find a mistake. You take water, right? W-A-R-E-T. You'll still read as water because every day you're seeing water, right? You don't understand the mistake. It's because of our psychologically, we see that every time. So yesterday I missed it somehow. Okay. So this is a typical city flooded. This is in Hyderabad city. These are temple tanks. Past olden days, all temples have a tank. These are basically rainwater harvest structure. And if you see this, that this is rainwater, and here you got a central portion where the filter, the water in the central portion is very, very clean. So water automatically gets filtered. People go in the morning, take bath in the temple, go to this place, collect water, and take home in their pots. That's how olden days people used to respect water, the cleanliness and water. Okay, this is some other temple. You just see this. It's a case for Hyderabad city. In 1991, the water requirement was 722 milliliters per day. What available was 545. Less. Then they tried to find other source of water. In 94, they got 680 mld. Population increased 4.35. Water requirement is so much. 10 years later, they could get more water. They're almost matching. And in 2011, they got some more water from other basins. It's more than what is required, but this is ultimate. There's no other source available. So even now, 2021, you find this is remain constant. This has gone back. So again, city is back to bad old days, right? You just see earlier less water. Again, so somewhere here they should have stopped. They stop urbanizing. No more colonies. No more this thing. Ask people to go out. Like Delhi city has called the Rohini satellite towns. People have to move and stay there. From there, you provide buses to Central Secretary, you provide buses to every place. So people don't stay in the city, they stay outside. Okay. This is probably the oldest water distribution network in the world. Northeast, Assam, they use bamboos. There's a Y-shaped stuffs. Water flows by gravity. Some place they opened it up for oxidation. This is the oldest water network. Later on, the Europeans took it and designed all the pipeline, equation, etc. This is existing by flowing gradually. It is from Assam. Okay, now these are the SDGs. So I just did low poverty, no hunger. So goal 1, good health and well-being, good quality education. Then gender equality, clean water and sanitation. So here they say ensure availability and sustainable management of water and sanitation for all. Okay. Then affordable and clean energy, decent work and economic growth, the industry, innovation, infrastructure, reduced inequalities, and sustainable cities and community. This also again water related. Responsible consumption and production. And climate action is again related to water. Life below water, that means fish, etc. And life on land. Then peace, justice, and strong institutions. Partnership for the goals. These are the 17 MDGs, which are now you have to focus on your future research. Now, when you do the system design, you take the economics, the public health, perceived risk, and you decide the recurrence interval, return period. What return period you have to go and decide, that depends on your economics, how much money you have. Larger return period you take, larger structure. Smaller return period take, smaller structures. Depending on the economics, public health, and perceptual risk, how much risk you perceive, you decide the selection period. Then from meteorology, you select the design storm. From the hydrology, select the design peak, calculate the peak flow. Hydraulics, choose the size of the conduits. Your simple hydraulic principles. So that's how storm drainage systems are done. And then this is something which I'll just show you something else. Yeah, this is something which I wanted to know. Swales. Swales are vegetated open channels. It's a drain being lined, you go for swales. When you line, what happens? No water go infiltration. Here we line with this. So these are vegetated open channels. They infiltrate and capture enough water. Because you are going to grow some vegetation, the water velocity will be low. When water velocity is low, all the sediment get trapped. And then vegetation are effective for removal of solids and retention of works. Okay. The simple Manning's equation reformulated. And then there are some numbers. this sub-equation here. The example is this. What swale length would be necessary to inflate all the water for the following data? I have given some number there. Equation that I gave earlier, I said 208 meters of swale is required. But I don't have 208 meters in the city. Then what do? See the next portion. I have only 76 meters. So what would be the volume? So I create volume there. It is possible in a city which is developing, not a developed city. When you're designing a new colony, when you're designing new towns, then you go for swales. So this is something which all of you have to think for designing. Not many books talk about swales, but there are certain books which talk about this. So stormwater reuse. The stormwater can be reused for irrigating open lands, recharging groundwater, supplementing water for cooling purposes, supplementing car wash water, enhancing creating wetlands, supplying water for agriculture use. All this can be used. Okay. Then you talk about water sensitive design. Okay. These are some nice pictures that you have. Flow control. This is swale. It looks nice. Right? Slope provides 1 to 4%. Then the marshland can vegetate it. Then this is a bioretention basin, constructed wetlands, infiltration system, sand filter, green roof. Who should be involved? This is very important. Public and community leaders, slum dwellers, land developers, farmers, environmentalists, and local politicians. Many books don't tell about local politicians. They must be involved because they are the ones who take decisions. Okay. Then you do some urban landscaping, piece of porous pavements, rain garden. Okay. There's another swale there. This is a stormwater planter, like where the rainwater comes, you just plant something here, so rain stops here. You have this. Then you have this type of things where water can enter the ground. So this is how these are all part of stormwater. It looks very nice. So you're having drains, you have this. Okay, you have street, road level. See here. Okay. See here, this again, where the water gets collected. This is another swale. So it's a drain, you have this. So it serves a lot of purpose. It enhances beauty. The land use value changes, land value changes. Okay, then use native plants. Don't use plants which are from other places. The reason is, when you have native plants, the roots will grow very deep. When you bring plants from other places which are not native, then the roots are like this. When you want to do a forestation of Bhubaneswar, bring plants which are suitable for Bhubaneswar. Don't bring something from Mumbai or Gujarat and plant here. It must be native. So native plants have this. So the deep root means it develops pore space. When the pore space is there, water will infiltrate. So more water will go into the ground. So this is something which you'll have to adopt. Okay. Then I'll give a small example of Aragal which we did. This is a case study. So here there's an open drain which carries all the water, wastewater, everything, large part of open drain. So this they wanted to treat it. The work was given to us. And what we did, we put a barricade across that. We widened it and put some pipes here. I can close and open. I can put a gate open. So when you widened it, what happens? All the solids will come to the top. I take it out. So I reduce velocity. When the velocity is reduced, all the suspended particles come to the top. That we did. Then we constructed a wetland. Okay, the construction is a pilot treatment wetland. We did it. Okay, there are two of my students who did this work, and then we filled up this. It's under construction. We filled up with clay. Then we planted these plants. This plant is again locally available. They belong to a family called Typha family. It's one of the best available, easily available in India. So we put this Typha latifolia plant. We did a lot of studies on this to find out how many plants to be planted. I said sometimes 4 to 6 plants per square meter. We planted this. And then the plants are pretty well grown. We used good water because before the experiment we wanted the plants to grow. And we also put fence around it because we don't put fence around it, people are spoiling it. So I put that. And then we put an inlet. That lady who's going there, she's Madam Margaret. She's one of the top post person in the world who does a lot of work on it. She's from Australia. So she came to see our plant and she was seeing that. See the one. And you see the results. the BOD was around this number. You see somewhere, we'll take just one number, 270, 280. Summer month, that was the BOD. Okay. And so that is the water quality. Then after we widened it, the BOD is this level, around 150. The blue color BOD, it came to from 250 around to 150 level. Just by widening that channel. Okay. So you see that it came that way, 166, 177. We take peak summer only. Other time you get rainfall anyway. Summer is the worst condition. So here, because of rainfall, it is lower. Here you find high. Okay. Then after it passes through the wetland, the other side coming around 13, 9, etc. Beautiful results. Okay. Now the water that comes this side is black in color. Other side we get crystal clear water. This particular tree plant, typha, attracts dragonfly. You know what is dragonfly? They fly like an helicopter. What do you call it? I know. It's called dragonfly in English. I know what you call it. You know that? You understood? It looks like a helicopter sort of. It eats, its main feed is mosquitoes. So what happens? This plant attracts dragonfly. Dragonfly eats the mosquitoes. So no mosquitoes there. And other side we got fishes and tadpoles. That means water BOD is very good. And that's what we got. So this just a small 5 cubic meters per head per day we diverted, and then we got this extremely good result. So I just compare summer months only. So raw waste water from 270 to 250, inlet 166 to 150, outlet is this range. That means I'm able to improve quality just by using the plants without any chemical, without any power. This plant cost me about 70,000 rupees. When we wanted the municipal corporate to construct a full-fledged plant, they were refused because it's cheap. Then they said low cost means they think low quality. Then I changed the name. I said it's not low quality, it's cost effective. Instead of calling low cost, I called it cost effective. The word changed. Then things start moving. So this I presented in a conference in Tanzania. Today, something like 200 plants are working in Tanzania based on the Warangal experience. They are doing a lot of things there. So these are some of the just compare the values. And you see the improvement, percentage improvement. BODs are 80 to 92% of the improvement in the quality. Okay, so each parameters. Yeah, I'll stop here. That's my slide again. And my last slide again. That is the plant. So that's the case study that I have. Okay. I have another 20 minutes. I just show quickly one wetland. You have a very famous wetland here, Chilika. Yeah, I have done a study for Renuka wetland in Himachal and another Pakal wetland in Deccan Plateau. We just compared. I just quickly run through that. And how many of you are comfortable with Google Earth Engine, remote sensing? GE, have you used Google Earth Engine? Please learn. It's free. You can easily learn it. It's available on the net. It's a free. Whatever I'm using, I don't buy any software. All are freeware. I mean, that's my philosophy. I don't accept any paid software. So I'll just show you quickly the wetlands. Yeah, this is a recent PhD work of one of my students. Okay, that boy got his MTech from IIT Kharagpur, PhD with me, and then he got a very, very good job he did. This we took two wetlands, one in Himachal Pradesh, other one in Deccan Plateau. I tried to compare using Google Earth Engine platform, which is free. We use two NDVI data. NDVI normalized vegetation index, and another one is water index. So these are two things used. Okay, so the objective is like this. So that's a wetland. So surface water occurs from lakes, etc. Wetlands exist in every country, in every climatic zone. So they're very, very available everywhere. And so wetlands are very important. They are rich in natural resources. They're very vital to human life. They act as water sources. They're kidneys for the nature. They call nature's kidneys. A world without wetland is called as a world without water. So this is very, very common. There's a big confusion between wetland and paddy field, where paddy field is a wetland or not. So there's a confusion going on between various state governments. And the general problem is the area is shrinking because wetland people start occupying the areas, they construct houses, tourist plots around that. That's a major problem. Then satellite data, we can get from satellite data, we can get a lot of information. So the major challenges are how to develop, integrate the management of wetlands, then address water needs of wetlands, develop a management plan, and map and monitor it. So we have something called Ramsar wetland. Heard of Ramsar wetland? They are internationally important wetlands. We got so many wetlands in our 75 Ramsar sites are in India. Okay, Chilika is one of the Ramsar sites here, and we have 3 in Kerala. We find many in Himachal Pradesh, Uttarakhand, Kashmir, okay, and many in northeast this area. Okay, here there's one lake called Loktak Lake. Loktak Lake is famous for what? Is famous for ornamental fishes. The fishes which are found in aquariums, big all colored one, they don't eat. They're meant for that. This Ramsar site supplies the best ornamental fish of the country. So these are all the wetlands available in the country. So we took up 2 indices, NDV, normalized different vegetation index, and normalized different water index. These are easy to calculate, readily available in the satellites. And then we use Google Earth Engine. It's a cloud-based platform for Earth observation and remote sensing data analysis. It's this GE can access all data available in the satellite imagery geospatial data from the cloud they can access. Then we can perform a lot of geospatial analysis and used by many of us for monitoring deforestation, etc. So that's the Google Earth Engine. You can see Google and get this. So it can Google Earth is 3D visualization. This is Earth Engine also gives you analysis capability. So there are a lot of data sets, then algorithms. You can put some requests, you get some results. So many of things are available. A lot of different types of satellite from Landsat to 5, 7, 8, MODIS, terrain, land cover atmospheric. These are all available there. And we took. I'll just skip this. So our objective first is monitor mapping and monitoring of wetland using GE. Second objective are time series analysis. What is time series? Any data which is collected in the same occurrence in which occurrence time, right? And then image classification, then change detection, how this change, and spatial distribution in time and global. Then you use the QGIS plugin, which is again available free of cost, to predict future LULC change. Okay, so that is the thing that I just did. So I just show this. This is Renuka wetland. It is in Himalayan region. This is very famous for 443 species fauna, 660 meters above sea level, and main problem is it's continuously shrinking. Okay, so that's the location of Renuka wetland, and you see this was in 2014, and here it is 2017. Just shrunk. The area has reduced a lot, and there's no human activities there. There are a lot of other activities going on. So this we show from that. And these are the NDVI data we collected. There are a lot of gaps here which can be filled up by gap filling techniques. NDWI data from Landsat. This again, we find some values are very low. Okay, then we calculated some indices. We call this SI. SI is called suitability index. If the SI value is below 0.18, that means that area is classified as a wetland. So here you find SI, these values you get. So 0.018, not 0.018. It's that means this area is a wetland. Okay, this for Renuka Lake, and then we took another lake in Pakal. You just see here, 2014, 17, 19. There is a lot of change. The area is reduced, and see how the area has been reducing. This we captured in a dynamic form. You can just see on the top corner. You got the year. See here. Year by year, from 87 onwards, I have data. So this we captured again using GEE. This can be done there. It's very, very easy. It takes about a week to learn. Nothing more than that. You have to just think that you have learned. You can do it. Okay. Again, we calculated the SI index here. So you can see how the area has been. This area in 2013. Now it is this. In between, it went up, and then it came down. So it was fluctuating. The map which showed that fluctuating. That's showed the perimeter also. And then this was declared as a wetland type, the Pakal. What we got us from our calculated SI. So this also Government of India has declared as that my calculations are correct. Okay. Then okay. So these are some I fit that missing values which I showed that earlier. I only showed so this is modeling of NDVA versus here. This is for linear trend. Some equation you can forget about this. This is we remove the trend, and this you can forget. And that's how we try to fix. We try to fix it as if it's a harmonical series, and we try to do this Pakal Lake, and we try to train this, and then we classified this. So that's how we find classifiers, random forest classifier, and we. So this is post classification. This is the classification before, classification later, and then how much land is lost. From the color change, you can make out how much is the change in the thing, and ultimately it's lost water pixel between 2019 and 20. That means this much area is lost from water. This is comparing these two. Okay. Then you find there, there's a raw image, there's a detected image. You find here this area, the red color, it shows how much area is lost. Okay. So then we found area change detection. You can see the two legs, 2016 and 2020. You can see all these areas. You can see this portion and this portion. That means the water areas reduced a lot. Okay. So here the water area is inundated. This is in 2018 when the heavy rainfall was there. And then we also calculated the surface water recurrence. This is in Renuka Lake, and this is how the water recurrence intensity changed. And we try to do the same thing for Pakal Lake, and you find water current change intensity. The water, see this shows there is decrease, no change, increase. That is where the green color there is increase, red color there is a decrease. So then we forecasted that how it's going to change. So these are maps of DEM is distribution model, slope, aspect ratio, distance from the road. And we found 6 categories: water, vegetation, flood, vegetation, etc. And we found how the LERC changed from 2016, 19, and 20. So you find this areas a lot of difference in here, here, and here. You can see the change. Okay, and then we found the area covered under each category. Then we validated. It's been predicted for 2016 to 18. Then use that for predicting for future. Yeah, I think I'll just stop here. So these are the papers that we got from his PhD thesis, which are all good work. And he also got a best paper award for this paper in one conference. Yeah, I think I'll stop here now. So you can share this. You can read. I skipped some of them because you can read at your convenience. And as I told you, my Gmail ID is there. Both IDs. You can write to me. I'll be very happy to answer any questions that you have.